class, in our last video we took a look at what our basic trig functions were. We found that the sine, cosine, and tangent all dealt with ratios of the different sides. In this video, the angle that we're going to be dealing with is this angle here, and this is a Greek letter alpha that we're going to be using for it. So we're going to be dealing with just this angle right here. Notice that in this right triangle, the hypotenuse, which is the longest side here, is across from the right angle, so it's going to be 3 square root of 2. And then the two legs are going to be 3, and one of them we're missing, so we have a variable x for it. When we're doing our trig functions, if you'll remember, we need to know where these two legs are in relationship to the angle that we're looking at. In this case, alpha is right here. So when we're looking at the opposite side of alpha, that would be the side across from it, which in this case is going to be the 3. The adjacent side to alpha is the one right next to it, which in this case is x. Our sine, cosine, and tangent were the ratios where sine of alpha was the side opposite it over the hypotenuse. In this case, we have those values. The one across from it or opposite it was 3, and the hypotenuse is 3 square root of 2. So if I wanted to find the sine of this particular triangle, I could already say that sine of alpha equals 3 over 3 square root of 2. Now, in the last video, we went ahead and left our square roots in the denominator and didn't do much other than maybe simplify our fraction by reducing the 3's in this particular case. In this video, we're going to actually take that a step farther because now we know how to rationalize denominators. So we are going to go ahead and simplify our sine ratio in this particular triangle by first going ahead and reducing our 3's. So 3 goes into 3 once. That makes this ratio turn into 1 over square root of 2. But we've found out now that we don't want to leave the square root of 2 in the denominator of a fraction. So we need to rationalize the denominator. In order to do that, we're going to go ahead and make this denominator a perfect square. The way we do that is we think about what the smallest perfect square 2 would divide into is, and that's 4. So if we can multiply this 2 by a 2, it'll turn into a 4. Since it's under a radical, we have to multiply by square root of 2, because you can only multiply things under a radical if they're both under the same one. So we're going to go ahead and multiply the top and bottom by square root of 2. What that gives us is square root of 2 over square root of 4. But we do know that square root of 4 is 2. So we're going to simplify this into square root of 2 over 2. If we were trying to find the sine of alpha, we would actually go ahead and simplify it all the way and say the sine of alpha is square root of 2 over 2. So we've taken things just a step farther into making it so that we have simplified ratios for our triangles. So we now have our sine. So I'm going to go ahead and move that over here to the side. We have sine of alpha. Now let's go ahead and erase this and take a look at cosine and tangent. Now, cosine and tangent both have this a in their ratio. Cosine is adjacent, that's what the a stands for, divided by the hypotenuse, which is what the h is. Notice in our particular triangle, the adjacent is missing. It's x, but we do have the hypotenuse. And I'll put our 3 back for the opposite. We need to find that adjacent. When you have a right triangle and 2 of the sides are given and one's missing, you can actually find the third side by using the Pythagorean theorem. Pythagorean theorem says that if you square the legs of a triangle and add them together, then they will equal the hypotenuse squared. Many of you may notice it as a squared plus b squared equals c squared. C is always our hypotenuse, and A and B are the two legs. So we can take the 3 square root of 2 and replace it for our c here. We can take the x and replace it for the a, and the 3 and replace it for the b. So let's go ahead and do that. I'm going to take the c and replace it with 3 square root of 2. And I'm going to put parentheses around that. That way we know that we're squaring the entire thing. My a is going to get replaced with x because that's what it is in my triangle. And my b is going to get replaced with 3 because that's what it is in our triangle. And I'm going to go ahead and put parentheses around that also, because when you plug a number into a formula, it's good to just stick parentheses around it to avoid mistakes. So now, if I go ahead and simplify this, I can actually do my 3 squared. 3 squared is 9. So this side becomes x squared plus 9. On the other side, when I square this 3 square root of 2, I have to square the 3, which gives me a 9, and that's actually being multiplied by the square root of 2 squared. And the square root of 2 squared is just 2. So this becomes 9 times 2. And 9 times 2 is actually 18, so we can actually just change this into an 18. Now what we have to do is we have to solve for that x squared. In order to do that, we need to move this 9 away from it. So we're going to subtract it from both sides. We'll subtract 9 over here and subtract 9 over there. That makes these cancel, and we just have an x squared equals 9. Now, in order to get rid of the square on the x, since it's just a single x term, there's no x squared and then x, there's just an x squared, we can go ahead and square both sides, or square root both sides. If we square root both sides, normally in a regular equation, you would put a plus or minus over here on this side. But in this case, we're talking about length, and length will never be negative, so we're only going to use the positive answer in this case. And the square root of 9 is 3. So now we know that x is 3. So since this is 3, we can go ahead and find our cosine and we can find our tangent. So let's go ahead and make a little room here. And we're going to go ahead and find our cosine. In this case, or in all cases, cosine is adjacent over hypotenuse. If we look at where alpha is, the adjacent or the side next to it was our x, which we now know is 3. The hypotenuse is the 3 root 2. So we're going to say cosine of alpha is 3 over 3 square root of 2. Now, wasn't that exactly the same thing our sine was? Our sine was this simplified to this, but it did start out as 3 over 3 root 2. So since we've already simplified it into this square root of 2 over 2, we know that this one's going to do the same thing. So we know our cosine is just going to be square root of 2 over 2. Now notice your cosine and your sine are exactly the same. Look at the triangle. This side's 3 and that side's 3. This is actually an isosceles right triangle, which means this angle's 90, this one's 45, and so is that one. When that's the case, when both these two angles are the same, because both these sides are the same, your cosine and your sine do actually match. And they will always simplify into square root of 2 over 2. Let's take a look at our tangent. Our tangent of alpha, if we look at our ratio, tangent of alpha is opposite over adjacent. So let's look at the opposite of alpha. That's 3. And the adjacent of alpha is also 3. So this comes out to 3 over 3, which equals 1. Anytime you have a right triangle that's isosceles, and these are both 45, you actually do end up getting a simplified form of tangent of 1. And as you move on to trigonometry, you're going to find that these ratios here are very, very helpful to know. So now that was one with a triangle that where the sides, the legs that were the sides of the triangle that were opposite and adjacent to our angle were both the same. Let's take a look at another triangle where they aren't going to end up being the same, but we still are missing some of the values. So we're going to find sine, cosine, and tangent of this particular triangle. Notice that in this triangle we have the adjacent to our alpha, it's 10, and we have the opposite of alpha, which is 5. What we're missing is this hypotenuse over here. There's nothing there at all. If we're going to use Pythagorean theorem to find that again, then what we want to do is go ahead and how about name that C, because in Pythagorean theorem C is actually your hypotenuse. So a squared and b squared, when we add those, we're going to get c squared. In this particular case, our a is 10, so let's replace it with that. And in this particular case, our b is 5, so let's replace it with 5. Now we can go ahead and simplify this and figure out what c is. So we know how to do 10 squared, that's 100, and 5 squared is 25. We can then add those together and get 125. Notice that our c squared is already by itself. We didn't have to move anything from one side or the other. But now we do need to square root. So let's go ahead and square root both sides. And again, since we're talking about length, we only want the positive value. We don't care about the negative value because length won't be negative. So on our right side here, the c squared, when we take the square root of that, the square root and the square cancel, so we end up with just c. On the other side, we need to simplify that. So we need to think to ourselves, what is the largest perfect square that will divide evenly into 125? And 25 does go into 125 5 times. So let's simplify this. It's going to turn into the square root of 25 times the square root of 5. And the square root of 25 is 5, so our c is going to be 5 square root of 5. That's the value we're going to use when we do our ratios. So this is going to be 5 square root of 5. Now we have all three sides, so we can go ahead and take a look at our sine, cosine, and tangent. Let's first look at our sine. Now, if you have a hard time remembering which ratio is what, there is a little saying that we mentioned in the other one, which is so, other video, so ka, toa. In this particular saying, S stands for sine, O is for opposite, which will go on the top of the fraction, H is for hypotenuse, it'll go in the denominator of your fraction. C stands for cosine, A is for adjacent, that will go in the numerator of your fraction, and H is hypotenuse, which will go in the denominator. And then we have T for tangent, O is for opposite, which will go in the numerator, and A is adjacent, which will go in the denominator. So let's start with our sine here. We need opposite over hypotenuse. Well, the opposite of alpha is 5, and the hypotenuse is 5 root 5. Let's write it down here because we know we're going to have to do some simplifying here. We have sine of alpha equals 5 over 5 square root of 5. Notice that the 5 in the numerator and the 5 in the denominator can cancel. 5 goes into 5 once. That gives us 1 over square root of 5. But now we have a radical in the denominator. We need to rationalize that. And in order to do that, we need to multiply the top and the bottom by the square root of 5. So let's do that. That gives us square root of 5 over square root of 25. And square root of 25 is 5, so this simplifies into 5 square root of 5 over 5. So let's go ahead and take this simplified answer here and put it up here for our sine. There we go. How about our cosine? Let's go ahead and take a look at that. Cosine, oops, of alpha is going to be your adjacent, which in this case is 10, over the hypotenuse, which is 5 root 5. So let's take a look at that. Adjacent was 10, that goes in the numerator, and hypotenuse was 5 square root of 5. So now we need to simplify that. Well, I noticed that the 5 divides evenly into that 10, so let's take care of that. 5 goes into 10 twice. So now we have 2 over square root of 5. But now again we have that radical in the denominator. We don't want that. So we're going to rationalize it. So let's go ahead and multiply the top and the bottom by square root of 5. That gives us 2 square root of 5 over square root of 25. But we can do the square root of 25. Square root of 25 is 5, so this becomes 2 square root of 5 over 5. So that's our cosine. Let's go ahead and move that up where our answers are. There we go. Whoops, my 5 moved a little bit there. Okay, now we have our cosine all set. How about our tangent? Tangent for this one's going to be the easiest one. Our tangent of alpha is going to be the opposite, which is 5, over the adjacent, which is 10. Notice we don't have to deal with the radicals in this one. So 5 over 10 is our tangent, which notice we can reduce that to 1/2. So our tangent of alpha is 1/2. And now we have all three of the basic trig functions.